Okay, so hi everyone, Senan this side, and in this video we are going to see how to solve this three-sum problem, right? And to do this, I would first request you to watch the two-sum problem that I have already uploaded and see what is the logic that we are going to use, right? And then after that, watch two-sum part 2, and if you do that, you will be able to solve this three-sum basically on your own, right? So that two-sum problem would be a method that we can use in this threesome, right? Okay, so what this threesome requires is you need to give a pair of triplets that sum up to 0, right? And the solution set must not contain duplicate triplets. Okay, so let's say we use an algorithm of n cube, like for I, j and k. We can iterate all over the list, find nums of I plus nums of j plus nums of k. If that is equal to 0, what we do is we return that in the list. What else we can do is, since we are not using any duplicates, rather than storing the answer in a vector of vector int, we can store this in a map or a set. What that will do is it will remove the duplicates, right? So that is one way. Now I'll just directly start with a bit more optimized approach. So if you use three iterators, right, I, j and k, and basically three for loops, what you would end up is with a function or this function with a time complexity of big O of n cube. What I'm trying to do is achieve, can we do this in big O of n square? So if you have sorted to some part 2, we can sort it in big O of, or we can solve that in big O of n time and with a constant space. So let's use that logic as well and implement this. So first of all, what I do is I declare the answer vector, right? So let's say answer. Maybe it's not the best naming convention, but it is what it is. So okay, so vector of vector int answer. Now what I will do is I'll assume, let's say, for int I is equal to 0, I less than n, and I plus plus, and so at least since I'm planning to have big O of n square, at least I can have one iterator, right? So now what is this n? N is nums dot size. Okay, but there was one, if you see the test cases, these elements are not sorted, but if you've seen to some part 2, that assumes that the input array is sorted. So if we sort, if I'm planning to do this in big O of n square, and if I sort the elements in this, sorting would take n log n time, right? And if that is the case, what happens is, if we use a big O of n square algorithm, that n square would dominate. So we can use sorting without affecting the time complexity of this solution, nums dot end. So that is the way you basically sort a vector int. You pass the starting and the ending iterator to this sort function. So this is n log n of time complexity, n log n, and okay, so we'll discuss the space complexity later on. Fine. Okay, so what I will do is I'll say, let's say int target is what, nums of I, and not exactly nums of I, minus of nums of I. So what I want is, so basically nums of I plus nums of j plus nums of k is equal to 0, right? So what I do is I take this nums of I remove it from here, and I'll say this is minus of this. basic maths. Now what I do is assume this is our starting point of array and this is the target. Now I want to find the 2 sum of a sorted array where the target is minus of nums of I. So this is very important. You have to do 2 sum part 2 to understand what I'm trying to do. So in this case, I'll say, let's say int j is equal to what? J is equal to what? J is equal to I plus 1. At least I go ahead a step of I because I don't want to repeat the same elements. And int k is equal to n minus 1, basically the last element. Now what I do is I do the same thing while j is less than k. What I do is if nums of j plus nums of k is equal to target, I do answer dot push back, and what I push back, what do I have to return? Output is the number itself, right? So we don't have to return the indices in this. So nums of I, nums of j, and nums of k, we return the we add this into our answer array. Now the case 2, if let's say if let's say I'll declare int sum is equal to this value, right? So I don't have to recompute the same thing again. So this goes int sum is equal to target. If sum is less than target, what does that mean? That means that nums of j, we need to increase the value of sum, right? So to do that, I can increase j by 1. So j plus plus and else k minus minus. Why? Because if the last case is sum is greater than target. To reduce the value of the sum, what I do, I decrement the k so that the total sum is lesser. Okay, this should almost work. Why almost? Assume if the array has duplicate elements, right? So this would actually result in what do we say, repeated elements, right? So we need to somehow take care of this fact. Now to do this, let's say if I have seen an I, a j, and a k such that their sum is actually 0. So what I do is, let's say if now if this is good, so that is the case. Okay, let me do this again. So when you push this, you should increase j by 1 and you decrease k by 1, because since you have already considered this pair, you are now trying to find a new triplet, right? So you need to update this as well. Otherwise j plus plus and k minus minus as we already did. Fine. Now the next thing we need to check is, let's say nums of j is equal to nums of j plus 1. So what happens is, after I do j plus 1, I would have the same nums of I would have the same value of nums of j, because nums of j is nums of j plus 1. And let's say if I also have a duplicate value of nums of k at nums of k minus 1, I would reconsider the same triplet again. So before I even start checking the sum, what I ensure is, while j less than k, right, and nums of j is not equal to nums of j plus 1, right? So at max what will happen is okay, if before this, if this is the case, basically equal, so if these two elements are equal, what I do is I say j plus plus. Similarly, if for k it is equal to k minus 1, so I do k minus minus. Actually, I am not currently seeing if these operations are exactly correct or not. So look at this. So if j is I plus 1 and k is n minus 1, let's say if j is equal to k, we would never get inside this while loop. Fine. Now since j and k are already always within the range of this nums, the length of nums, so j less than k is true, and nums of j is equal to nums of j plus 1. So this would ensure that j plus 1 would always be within range because j is less than k and k is within range. So even in the worst case, j plus 1 would be k, right? And similarly in the case 2, I do this k minus minus, and this should do the job partially, right? Now we need to consider the fact that after doing this, we are still within the, so j is not equal to k. We need to ensure this, right? So what okay, so here I have done this. A different method would be, rather than if I found a solution, what I do is I take these two while loops, I go inside, right, and I do this. Rather than doing for all possible cases, we only do this when we have already considered j as an answer, right? So in this case, we would increase j plus plus and k minus minus. So when I wrote this outside, that was wrong, because if that was the case, we could have skipped some things. So we are only skipping in the case where we have already considered those elements, right? After this is done, this is else if. After this is done, I can go back to the while loop, check j is less than k, and do this. Now this is still not complete, right? We also need to check, we ensure that j and k are always unique to nums of I. But what I need to also check is I should not be repeated as well, right? So if the first two elements are same and I, j and k are found, so I plus 1, j and k would also be a solution. So I say if I is greater than 0, what I do is not just this, and I is greater than 0 and nums of I is equal to nums of I minus 1, I say continue, and this should probably run. Let's see this. Okay, so this is running properly. Fine. Yep. So let me just submit this, and we'll then discuss the time and space complexity of this problem. Okay, we did something wrong somewhere. Okay, let us check what we did wrong. Okay, this I think is correct, because if we have found an I, or we should not go towards the same I twice. Target should be minus of nums, and start from this. Okay, sums is nums of j plus nums of k, that is also correct, and sum is equal to target. That means we have found a solution. And okay, got it. So the problem is we have already increased the value of j. So rather than checking j with j plus 1, which could be same but won't be equal to the value of j in this case, right? So rather than j plus 1, we check with j minus 1 and k plus 1. Again, still the values would be within range. Okay, so sum is less than target, so I increase the j, or otherwise I decrease k, and then I return the answer, and then I would submit this, and this should work, right? There was a small issue in the indexing of the arrays, my fault, and yeah, this is very well accepted, and I think this is good now. Okay, so let's discuss the time and space complexity. As I said, time for this sorting is n log n, and if you look in this for loop, we are iterating towards I to n. Obviously, if you want, you can do this n minus 2 as well, because this at least you need 2 more elements, at least you need 3 elements, right? So it, even if you go to n, that won't be considered, because this condition would always be false. Anyways, so you have one for loop, so that takes a complexity of n. Let's see what happens inside. So we are taking 2 iterators and iterating over the rest of the array at the same time, right? So this while loop is again order of n, this for loop is order of n. So this whole for and while loop in itself is big O of n squared, right? And this is n log n, so n squared dominates, so the time complexity is n squared, big O of n squared, or the order of n squared. What is the space complexity? Space complexity is the number of answers you could possibly have, right? And let's say you don't consider the space complexity of the answer, because the size of the answer depends, right? In the worst case, the answer would be n choose 3, because all elements are unique, and for some reason we choose all possible triplets in that list, but that won't be the case, more or less. And assume that we don't use this answer, or we don't consider the space complexity of this answer, right? So what would be the space complexity? Okay, so int n is constant regardless of the size, like constant size, like not n is not constant. We are declaring 3 more numbers, we are just checking a number, we are not using some extra space apart from this. But even if you don't consider the space complexity of the answer, you need to keep in mind that depending upon the implementation of this sorting algorithm, sorting can be done in n log n, but it could depend if it is using extra space or not. So merge sort uses extra space, quicksort does not use extra space, but it, on average, quicksort also solves in n log n, right? If the pivot is nice. So the time complexity of this problem would be big O of n square. Space complexity can be big O of n depending on the sorting algorithm, and in the worst possible case, n choose 3, which I don't think would be the case, because not all triplets of unique elements would actually sum to 0, right? So in the worst possible case, n choose 3, that won't ever be reached. I think that is all I have to say. Okay, before ending the video, I'll just tell you what all mistakes I did. Since I incremented this j and decremented this k, I forgot that I had this j is not the j that I had considered previously. So compare j with j minus 1 and k with k plus 1, right? That is what we had to check. Another thing that we did wrong was we took this while loop and placed before the sum. That is wrong because first we need to make sure that we have taken the elements. If we consider we have taken some sort of elements, then and only then we are changing j and k. Okay, and let's just check if this works if I put this outside, right? Just randomly. I don't want to think much, but let's just see if this is causing any sort of error. Clearly this gives the wrong answer, right? So even in the test cases, so we need to have this inside. And what mistake did I do otherwise? I don't know exactly. Okay, so we needed to check that we don't use nums of I, the same value of nums of I again and again. We ensured in this while loop that same value of nums of j and k is not used again, and we appropriately traverse this array, the remaining portion of the array. And yeah, that was the video, guys. Hope you enjoyed this. If you enjoyed this, be sure to hit that subscribe button if you haven't already. But more important than subscribing is to share this video with someone who could actually benefit from these videos, right? So yep, that's the video, and bye.